So let's go over these 5. So 76, you've got the graph of f prime, or the derivative of f. And then it says, on what intervals is f increasing? Oh, sorry, I was going to give you all the answers before we went over this. Let me tell you what the answers are first, and then so you can check how you did. Here we go. Okay. 76, the answer was B. And 73% of people got that right. 77 was C. 57% of people got 77 right. '78, the answer was B. 71% of people got that right. 79 was B.
Is it B?
On 79. 55% of people got that right. And then number 80 was E. And 40% of people got that right. You didn't get any right?
No.
Okay. How'd the rest of y'all do?
I got 3.
You got 3 of the 5? You got the first one right?
I was really confident.
Okay, so the first one, it's asking you when f is increasing. So we know f is going to be increasing anywhere that its derivative is positive, right? Anywhere that the slope is positive. The slope or the derivative is positive. But the thing about this is that this is the graph of the derivative. So that means that the y values of this graph are the slopes of my function. So when I look at this graph, I don't look at the slopes. I look at the y values. Where are the y values positive? And that's between -2 and +3. The y's are all above the x-axis there. So it should be
Wait, so
B.
like when the y's are positive?
Yes, because we're looking for where the derivative is positive, and this is the derivative.
So like for the first one from like negative, I don't know, like line 0. I don't know. Like how are they? Actually, never mind. This is my question.
You got it?
Yeah, I just like.
You sure?
Yeah.
These were hard for me when I first started teaching calculus because we didn't do problems like this whenever I had to take calculus, and so it took me a little while to get used to this whole graph of the derivative but answering questions about the function kind
If
of
it
problem.
wasn't the graph of derivative, would it be determined the same?
Yeah, if it wasn't the graph of the derivative, if it was the graph of f, we would just look at the slopes.
Okay.
But they're not typically going to ask that. They're going to show you the graph of the first or second derivative and ask you about the function.
Oh, okay.
It's not very often they give you the graph of the function. Okay, so then on 77, this is a limit problem. We haven't done limits since last semester. So the figure above shows the graph of a function f with domain 0 to 4. Which of the following statements are true? The limit as x approaches 2 from the left exists. So here's 2. And so it's saying, can we approach a specific height on this graph if we come towards 2 from the left? And we can. We watched a little video when we did limits where the guy was like going to meet somebody at a diner, and even if the diner like caught on fire and burned down, you could still meet there. So even though when we get to 2 from the left, there's a hole there, we still get to a height. That hole has a height, so we still get somewhere, even if there's a hole there when we get there. So this exists. And the limit as x approaches 2 from the right, yeah, we get to a height there. That exists. But because these heights don't match, the heights at 2 don't match when we come from the left and the right, then this is called the general limit, and it doesn't exist. Because you don't meet up. It's like that
By
whole
matching,
diner
like,
metaphor.
they don't
Yeah,
touch.
they don't touch.
Okay.
They have to meet up. Okay, and so we're on the calculator portion, and so far I haven't touched a calculator. So just because you're in the calculator portion of the test doesn't mean that you're going to use the calculator on every problem. We are, however, going to use it on this one. I can tell I'm going to use it on this one because the answer choices are all in decimals. So it's kind of a good indicator on the calculator portion that you're going to be using the calculator. Okay, so it says the first derivative of the function f is defined by this equation for 0 to 2. On what intervals is f increasing? This is actually the exact same problem as 76. But instead of giving you the graph, they gave you the equation for the graph. But other than that, what it's asking you is the same. So I'm going to work it the same way. I would graph this equation here. So I'm going to go into my calculator. I'm going to go to the graph. I have some stuff in here, so I'm going to clear it out. So I'm going to press menu and actions.
Because when I graphed it, just
Well, we're just going to graph the equation. We're not going to, I mean, we know that the equation we're graphing is the derivative graph, but we're just going to graph it just like it looks. So we're going to type in the sine of x to the third minus x, right? We might need to check the settings on the calculator. Let me go. I'm going to go to settings real quick and make sure. Oh, I am in radians. Okay. Make sure. Yeah, and before the AP test, I'll set all the calculators to make sure they're set right. But you go back to the home screen and go to settings, and then go to settings again, and then it's general. Yeah, and where it says angle, you want that to say radian, and then you want to be sure that you choose make default. If you just choose OK, it only applies it to the documents, and I think most people don't open a document when they're doing stuff. They just use the scratch pad, so I'm going to say make default. Okay. So now when I go back, okay, so the graph still looks weird. The reason it looks weird is because the window is set to go from -10 to 10, so I'm seeing all these weird parts of the graph, where really all I want to focus on is this section of the graph from 0 to 2. So what I would do is actually change the window so that that's all I see, so that I don't get confused by all this other junk that's going on. So I'm going to go to menu, and then where it says window and zoom, I'm going to go to window, and then window settings. And I want my x's to only go from 0 to 2. Whoops. The rest of the stuff you can leave the same, but we just want to look at the right little domain here between 0 and 2. So I'm going to say OK. Okay, so now I can see a little bit better. I probably would play with this a little bit more just because I don't like how close to the x-axis is, so I would probably decrease some of my y values too. But I'm just kind of weird that way. There, I can see it a little bit better. Okay, so we said on 76 that when we were looking at the graph of the derivative, we could tell if our function was increasing if we looked at where the y values were positive. So we're going to do the exact same thing on here. We're going to look at the graph of the derivative that we just graphed in our calculator, and we're looking for where the function would be increasing. So we're going to look at where the derivative is positive, which means that we're going to look at the y values on the graph of the derivative that we just made. So that would be from here to here, right, where it's above the x-axis. And so you can calculate those 2 points by finding the zeros of the graph using the calculator. So if we go to menu, analyze graph, and the very first thing is zeros, it'll bring up a little dotted line and a little hand, and it'll say lower bound. You just got to scroll that so that it's to the left of that 0 that you're trying to find. Anywhere to the left, it doesn't matter as long as it's to the left. And then you click, and then it should change to upper bound in the corner. And so I can see right there that that 0 is at 1. Right? If I do menu, analyze graph, 0, and then lower bound, you got to put the little dotted line to the left of the point. And then upper bound, you got to put the little dotted line to the right of the point. And it should make like a little grayed in rectangle, and it'll pop up with a little point when it finds the zero. Does that make sense? And so then you'll just repeat that same process for the other zero. So we've got 1 and 1.69 something. So that would be B. Right? So they actually asked you the same question twice. One of them you used a calculator and one of them you didn't, but you're in the calculator portion. So, okay, so let's look at 79. 79, they give us the integral from -5 to 2 and the integral from +5 to 2, and they want the integral from -5 to 5. So if you think about we've got some graph, I don't know what it looks like, but we've got some graph that goes from -5 to 5. Right? And they tell us that the area under this curve from -5 to 2, so this area here, between -5 and 2, is -17. And then they tell me the area from +5 to 2. Well, what's wrong with that little integral right there? It's going the wrong way. This is saying 5 to 2, and we should always go left to right, or smallest to biggest. So I can fix that, but what do I have to do to my value over here? If I switch the bounds, what has to happen to this? It has to switch its sign, right? So then that's saying that the area from 2 to 5 is 4. And so then it wants to know what's the whole area from -5 to 5. So if from -5 to 2 was -17, and from 2 to 5 was 4, then the whole area would be -13. You just add them together.
And then if you didn't switch the bounds, would you just subtract 2?
Yes. Yeah. Okay. And then the last one, number 80, the derivative of a function is given by, and they give us the equation for the derivative. How many points of inflection does the graph have on the interval -2 to 2? Okay, so when we look at our graph, points of inflection happen if the second derivative changes signs. And when you look at the graph of a derivative, what characteristic of that graph tells you information about the second derivative? If I have the graph of f prime, and I want to look at where f double prime, or the second derivative, changes signs, what am I going to look at on the graph of the derivative that will tell me about the second derivative? That would be if I was looking at the original function. The slopes. Right. The slopes of this graph, the slopes of my derivative graph, are my second derivative. Right? Because if you think about it, how do I get from the first derivative to the second derivative? I take the derivative. And taking a derivative means that I'm finding the slope. So if I graph this, so I'm going to graph this. X squared cosine of x squared, and I'm doing this on the window -2 to 2, so I'm going to fix my window to go from -2 to 2. So how many times does the slope change signs in this little window here? Let's see, we've got positive slope, and then right here at the top we change from positive slope down to negative slope. Then right here at 0, at this little minimum here, we change slope again, And then we change slope one more time. So we've changed slope 3 times.
When it says -2 and 2, is that your x?
Was the answer C?
The answer was E.
Why was the answer E? X squared cosine of x squared. Selection. I don't see why it would be E. Why it would be. Type something in wrong. No, I did not. I don't agree with that at all. 1, 2, 3. Well, I don't agree with that. I don't think it's supposed to be 5.
Wait, Miss Craig, when it says -2, 2 on your settings,
Mm-hmm.
when you do standard or whatever, I mean, your settings, do you do it for the Y's or minimax as well?
The Y min and max, you can make whatever you want.
Oh, okay. You just do maybe one.
Yeah, you just got to make sure that the X's are right. Okay, well, I don't agree with that. That's supposed to be E. So I'll put out an email to some of the other calculus teachers and find out what it is I'm missing. But I say it's supposed to be 3.
And so you just like for when the sorry, I was like behind the step. You just like for when the slopes change.
Uh-huh.
Okay.
Yeah. All right.